Okay, we're taking a look at question 16 out of 9-1. In a randomized controlled trial in Kenya, insecticide-treated bed nets were tested as a way to reduce malaria. Among 343 infants using bed nets, 15 developed malaria. Among 294 infants not using bed nets, 27 developed malaria. We want to use a 0.01 significance level to test the claim that the incidence of malaria is lower for infants using bed nets. Based on the results, do bed nets appear to be effective? So first thing that we want to do is go ahead and identify the claim. And our claim here is that the incidence of malaria is lower for infants using bed nets. So translating it, the proportion that get malaria using bed nets would be lower, less than the proportion that get malaria not using bed nets. And the opposite of that would be the greater than or equal. So we identified the claim, we identified the opposite. Now we can go ahead and write our null and alternate hypotheses here. So whichever one we listed first, we still list first. So that's going to be our sample one if we listed it first. Whatever got listed second, that's going to be our second sample. Now, what goes between them? Well, in the null, it is the equal because it's always equal in the null. In the alternate, we want the strict inequality, that is the strictly less than. And now when we do a little bit extra for the conclusion, we put the R and the S, and we want to know which one looks most like, if not identical, to the claim, and that is the alternate hypothesis. So when it comes time for us to write the alternate hypothesis, we're going to be writing in support of the claim. Do we or do we not have the evidence to support the claim? So our inequality in the alternate is pointing to the left. This is a left tail test. Our significance level is alpha, that's 0.01. And identifying our pieces here. So our sample size and number of successes. Well, sample one, that is the way that we've set it up for the bed nets. Sample two is the not bed nets. So 343 use bed nets in total, 15 of them develop malaria. And for those not using bed nets, there was 294, of which 27 developed malaria. To go ahead and write our rule of rejection, I list both options, but I'm always using the p-value versus significance level, which means we're going to write the rule of rejection as reject null hypothesis if p-value is less than or equal to our alpha level, which was 0.01. Now we're ready to head over to StatDisk to get our test statistic and our p-value. Because for proportions, we use the normal approximation. Our test statistic is going to be z. If you didn't know that ahead of time, that's fine. StatDisk would tell you. And then I'm intentionally lining up my p-value underneath my rule of rejection. That way I can line up by place values so I don't do anything goofy when it comes time to make those comparisons. So now I'm going to head on over to StatDisk. So we don't need that. So analysis, hypothesis testing, and this is a 2 samples proportion case. Our alternate hypothesis, it was a less than. This is a left tail test. Our significance is 0.01. And it's the importance of getting these 2 items right is the alternate hypothesis will give what the p-value is, depending which case. Does it give you the left, the right, the 2-tail, and the alternate hypothesis in conjunction with the significance level, that's going to generate the critical value or critical values. So that's what that information is telling us. And then now we'll put in our information for sample 1 there, our information for sample 2, and then we can go ahead and hit evaluate, and we can hit plot as well. So the important information that we're going to be taking back from this is our z-score, which is -2.439. I'm taking it as it's shown on the plot screen. And then our p-value, that is 0.0074. We also, in terms of what we're looking at here, and I think I'm going to go ahead and just copy this over. So let's head back to here. Let's see if it'll good. So our z-score was -2.439. We're just shy of 2.5 standard deviations below what we would expect if these 2 population proportions were the same. And our p-value is 0.0074. Because common mistake I see is people comparing the 1 and the 7. They're in different place values. So we make sure that we compare place value to place value. And if you wanted to, you could always tack on a couple zeros after that. But here, our p-value is less than alpha. We said we would reject the null hypothesis if that was the case, and that is the case, so we reject the null hypothesis. And when we reject the null hypothesis, that means that we have the evidence. So we have sufficient evidence to, and since we circled the S up here, S is for support. Support the claim that. And then the next thing that we do is we literally go ahead and copy our claim word for word there. So our claim was the incidence of malaria is lower for infants using bed nets. So now that we've written our conclusion with respect to the claim in its 3 separate pieces, it's best to go back and read it all the way through. We have sufficient evidence to support the claim that the incidence of malaria is lower for infants using bed nets. We rejected the null hypothesis. We rejected the idea that the proportions were the same for those using bed nets and those using not bed nets. When we reject the null, we go with the alternate, and the alternate is saying that the proportion that get malaria using bed nets is lower than the proportion getting malaria for those not using bed nets. And again, this is for the entire population. So we do have the evidence to support this idea. So the purpose of bed nets is to reduce the incidence of malaria. Do they appear to be effective? And our answer to that is yes. Quite simply, yes. We were able to support the claim that they work, so yep, they appear to be effective. Now, if we wanted to go ahead and make the decision using confidence intervals here, we should take a look at our confidence interval here, and our entire confidence interval is negative. When our entire confidence interval is negative, that says that it would appear that proportion 1 is less than proportion 2. Or in our case, the proportion using bed nets is less than the proportion not using bed nets, which is the same conclusion we reached with using the hypothesis testing method. The number that we're looking for in terms of the confidence interval, in terms of rejecting, failing to reject, typically is the 0. Our confidence interval doesn't contain 0, and 0 is the case where these things are equal. So confidence interval doesn't contain 0. So the idea that these two proportions are equal, that seems to contradict that. So that is number 16 from chapter 9, section 1.